Yeah, welcome everyone. So in this session, we will see about implementation of stack using a linked list. In the last session, we have seen implementation of stack using an array. So what's the meaning of stack? Stack means to storage of data. It's a linear type data structures. And then in the stack, we have seen operation called push, pop, peek. So push means what? Insertion of data. So at first you have to check for overflow or not. If it's not overflow, insert a data. Pop means at first you have to check for underflow or not. If not, remove the data. Peek means it will show the top element from the stack. So now here we are going to implement the stack concept using a linked list. In a linked list, there is something called node. What's a node? Node is comprises of an data field and then the link field. The data field is the data. You can see here. It is a stack size. Stack size is 6. So 0, 1, 2, 3, 4, 5. The stack size is 6. So each corresponding index will be having a node. So for example, a data field and link field. Okay, data field and link field. So now what happened over here? So in the linked list, the arrangement of data will not be in consecutive memory locations. It can be random. It can be random. So I can store wherever I want. I can store the data wherever I want, but I will create a link from one node to another node. For example, the first data is 7 and then the link is 0, null. The link is null. Okay. So now the top is the address is there is something called 100. So in the 100th memory location, I have stored a data called 7. So top is equal to 100. Top is equal to 100. So now I am going to insert a new data. There is something called 9. So now it should create a link to the next node. So the corresponding the next node is going to be the node which is below the top data. So this is 100, right? So I'll give top value over here. So the link is created between this first node and second node, the first data and second data, and then the top will be updated to the 110. Top will be updated to the 110. Then I will enter the third data. That is something called 4. Then here the link will be created to the top data because the top should be keep on updating. So now I will give the 110. So now what happens over here? Once again, the top will be gets updated. So it will update it to 210. So now you can observe that 110. So first top element is 4. So I have stored there is some memory location called 210. Okay, and then it's linked to the 110. So after 4 data, it will come to the 110. It will take the 9 data called 9. And after that, it will go to 100 memory location and go for the data called 7. So in the previous implementation of stack using an array, if you observe, the memory locations were consecutively, it's sequential way. But whereas here, it is very much random. It is very much, memory locations are very much random. Memory locations are very much random over here. 100, 110, 210. There is something like that. But still, we are able to create a link from the one node to another node. So for this operation, we will write a code using an C. So at first, as usual, we should create a node. We should create a node, define the structure of a node. So we will define the structure of the node. Struct node. We have two different data types, integer and then the pointer, which is corresponding another structures. So struct node asterisk link. So if you have any queries on this linked list, we have another previous sessions. You can check it out over there. And then here, once structure is created, we'll go and perform the push operation. So now initially the stack is empty. Initially the stack is empty. So I will declare the top as a null. I will declare top as a null. Initially corresponding top is stack is empty. Top is equal to null. So then we'll go for an push operation. In the push operation, what happens over here? We will go and create a node. Okay. So in the arrays, we will check for an overflow condition, and then the pop we will check for underflow condition over here. But here in the linked list, there is no need to check the overflow condition because here the size is not limited; it's unlimited. Wherever we want to store, we can store a data. So there is no need to check the overflow condition or not. So void push and integer is x, and then the new node is the local pointer variable, and then already we people know that how to given memory allocation for the new node. So if you have any doubts on this, how to give a memory allocation, go and check it out in the linked list video. So new node is equal to struct node malloc size of struct node. So once new node is created, in the new node, for example, this is a new node. This is a new node. In the new node of data position, I will store the variable called x data 5. So here we have got data called x, right? So in the x variable, I have got 5. So in the new node of data, I have stored 5. So here you give new node of data is equal to x. New node of data is equal to x. So once data gets stored, then what should I do it over here? In the link place, I should store the top address, the top value. Am I right? So 210 should be stored over here. Then only the link will be created to the below datas. So now here in the new node of link, I should store the top. So at present the top is 210. At present the top is 210. So in the new node of link, I will store the top. So the new node of link is this place. I should store the top value. What's top value? 210. So once data has been created and the link has been created, then I should update the top value. So the top will be equal to new node address. So this is a new node. This is a new node, right? This new node will be having an address. That's what we have done in memory allocation. That address that will be having one address. That address will be assigned to the top. So this top has been updated to the 310. So top is equal to new node. Top is equal to new node. So this is an operation called push. Very much simple one. At first, we have declared an new node local pointer variable, and then we have allocated memory space for the new node, and then the new node of data portion we have stored the x, and then the new node of link we have stored the top address, and then we have updated the new node address to the top. This is called push operation using a linked list. So now we'll go for an display of data. Okay, whatever data is available, it will go for display of data, right? So now here I have declared local variable pointer variable as a temp, and temp is assigned to the top. So what's the top over here? The top is 310. Top is 310. So 310 has been assigned to the temp. So temp is equal to 310. So now if top is equal to null, then stack is empty. Okay, but here in our case, the top is not equal to null. So we'll go for else condition. So in the else condition, so at first, until the temp is equal to null, I should keep on going for the data. So now what do we do? Do it over here. I will print the top element. So here temp is 310. Temp of data, 310 of data is 5. Then that will be gets printed. Then I will update the temp. Temp will be equal to temp of link. So 210. So is equal to 0? No. So once again repeat. 210 of data is 4. I'll print it. Then I will update the temp variable as here 110. Is it equal to 0? No. Then 110 of data is 9. Then I will update the value of temp to 100. Is it equal to 0? No. Then repeat. 100 of data is 7. And then temp will be updated to the 0. It's equal to 0. Then this loop gets failed. Then I have printed all the elements in the stack. Okay, this is the operation. So here I'm going to use an while loop. While temp is not equal to null, while temp is not equal to null, I'll be keep on repeating the same step. I'll be keep on repeating the same step. So while temp is not equal to null, I'll print the temp of data, and then temp will be updated to the temp of link. So temp is equal to temp of link. So our present temp is 310. Temp is equal to temp of link. So 310 of link is 210. So temp will be equal to 210. Then once again, while loop gets verified. Temp is not equal to null. It will be temp is not equal to null, right? So it will be do it once again. So until it becomes null, it will be keep on repeating. This is operation called display. It's simple one. At first, you check for stack is empty or not. Else, until temp is equal to null, it will print the data of nodes, and then keep on updating the value of link positions. This is called display of data in the stack using a linked list. So then we'll go for an pop operation. We'll go for peak operation. We'll go for peak operation. So once again, the peak operation, once again, we will check if top is equal to null, stack is empty. If not, it will print the top of data. So if top is equal to null, the stack is empty. Else, it will print the top of data. What's the top over here? The 310. The 310 of data is 5. The 5 will be gets printed. So this is a peak operation. So then now we'll go for pop operation. So in the pop operation, if top is equal to null, the stack is empty. And then if not, then what happens over here? We will we'll remove the top of data, the first element in the stack. Okay, so we will remove the element. So until stack is empty, we will do it in the code. So pop, and then we have declared a local variable called temp, and temp is assigned to the top. So top is equal to null, stack is empty. If top is equal to null, stack is empty. In our case, top is not equal to null, right? The top is around 310. So now what do I do here? I should delete this node, right? So pop element is top of data is equal to 5. Okay. So the top of data is 5. We will remove it, and then we will update the top. We will update the top. So top is equal to top of link. Top is equal to top of link. So now here, what happens over here? Now our present top is 310. So if you remove this data, then the top should be equal to 210. So where the 210 is available? In the top of link. In the top of link, I have 210. So what I'm going to do it over here, I'll pop the element is top of data, and then what I'm done over here, top is equal to top of link. So the 310 is a top. 310 of link position is 210. Okay, this is a data field, and this is a link field. This is a link field. So the 310 of link position is 210. So top is assigned with 210. And then we will free the memory space of temp. That means the 310 corresponding memory space has been freed up. and then we will close the parenthesis. So this is the operation of pop. So at first we have checked for stack is empty or not. If it's empty, then stack is empty. If the top is called null, that's the stack is empty. Else we have popped the element top of data, and then we have updated the value of top to the link field value. Okay, so top is equal to top of link, and then free the memory space of temp. That means free the memory space of first data. So this is the operation of pop. So through this session, we have covered implementation of stack using a linked list for push, display, and then peek, and then pop. Okay, thank you.